Hey guys, this is Mrs. Harmon, and we are going to continue our chapter here on inequalities with section 4.5, which is all about disjunctions. Last class we learned about conjunctions, which are the solutions that will satisfy two inequalities. That solution is in both one and the other. Remember, we said conjunctions, we need to remember both and. A, B, C. A for and, C for conjunction, and B for both. A, B, C. All right, today though, we're going to look at disjunctions. Our objective for today is that you, the student, will define disjunctions plus solve and graph them. So let's start by defining disjunctions. A disjunction is a compound sentence consisting of mathematical statements connected by the word or. This is going to be our symbol. Conjunctions had the symbol for and, which was this sign, and disjunctions have this sign for or. Now, looking at some English here, dis means not and junction means joined. And what this means is that disjunctions don't have to overlap. We're looking for any solution that will work for either one or the other. The solution doesn't have to work for both, like a conjunction. So any solutions that will work for one or the other are the solutions in a disjunction. So in order for a disjunction to be true, only one of the statements must be true. If our keywords for conjunctions, let's write these up here, our keywords for conjunctions were both and. We were looking for solutions that were in both one equality and the other. Our keywords for disjunction, and sorry, my handwriting is really terrible with this mouse. The keyword for disjunction is either or. Either or. We're looking for solutions that will work for either one or the other. Now, it might work for both inequalities, but it doesn't have to. And we'll see some examples where that's the case. So let's take a look at this number line. We're going to graph the solution set of x is less than -4 or x is greater than 1. Here's our symbol again. We're going to look for solutions that will work for either one or the other. Just like before, we're going to graph these two inequalities separately. So in red, we're going to see x is less than -4. Open circle at -4 and going to the left because less than goes to the left. And x is greater than 1. An open circle at 1. Greater has an R, greater, which is going to help us remember it goes to the right. Our arrow goes to the right. And we want to ask ourselves which of these would work for one or the other. Well, anything less than -4 would work for the red inequality, and anything greater than 1 would work for the blue inequality. So our solution set is these two lines. That x can either be less than -4 or greater than 1. Either of those will give us a solution to at least one of our inequalities. So conjunctions had to work for both. Disjunctions have to work for either one or the other, and these numbers will work for either one or the other. The symbol used, and you've seen me use it already, for disjunctions or for or is the symbol that looks like a V. Disjunctions, unlike conjunctions, cannot always be written as combined statements. With conjunctions, we could write it as one statement. Disjunctions are not always the case, although sometimes they are. Another helpful tool, if you want to remember this, this is very similar to our symbol for union. When we did number sets, we were talking about set theory. And basically what we're looking at is the union of these two inequalities. What numbers are covered by all the inequalities when we graph? What numbers are covered? What is the union? I don't know if that will help you remember that. Maybe you have a better memory trick to help you remember that a disjunction is either or, and that is the symbol. Let's take a look at these two. We have x is less than 4 or x is less than or equal to 2. We want to know what solutions would satisfy either or of those inequalities because we're looking at disjunctions. This symbol right here is telling us either or. So let's graph the red inequality. X is less than 4 looks like this. And our blue inequality, x is less than or equal to 2. And you can see that this time they do overlap a little bit. So which values will work for either one or the other? Well, anything less than 4 will work for either one or the other. So our solution is x is less than 4. Any value less than 4 will work for either one or the other. Now, in some cases, it will work for both, but that's not what we're looking for. We're just looking for the ones that will work for either one or the other, and sometimes both. Let's try this one. 3x plus 4 is greater than 16, or, let's use our symbol here, negative 5x is less than or equal to 20. Well, the first thing we need to do is solve both of these for x. So let's use what we know about addition and multiplication properties and our inverse operations to solve for x. And when we do that, we get x is greater than 4, or x is greater than or equal to negative 4. Let's go ahead and graph this. Graphing the red inequality, we get x is greater than 4 looks like this. And graphing the blue inequality, we get x is greater than or equal to negative 4. So which numbers will work, which numbers on our number line will be solutions for one or the other, and maybe both. In this case, anything greater than or equal to negative 4 will work for one or the other. It does not have to work for both, it just has to work for one or the other. So negative 4, negative 3, negative 2, 0, 1, 2, and 3, those will all work for this one. And then anything greater than that, 5, 6, 7, those will all work for the red inequality in addition to the blue one. Remember, disjunctions, we're just looking for solutions that will work for one or the other. It doesn't have to work for both. Again, it's kind of like if you took these two and you laid them one on top of the other, which numbers would be covered by both of those lines? Not where do they cross, but which numbers, when combined, do they cover? Okay, let's take a look at these two inequalities. We've got 3x minus 6 is less than or equal to 12, or 5x is greater than negative 25. When we solve for x, we get x is less than or equal to 6, or x is greater than or equal to 5. When we put that on a number line, x is less than or equal to 6, starts at 6 and goes all the way to the left, and x is greater than or equal to 5, starts here at negative 5, open circle, goes all the way to the right. If we were to take these two lines, the red and the blue line, and put them both on top of the number line, you would see that the red line would cover everything from 6 to the left and keep on going for infinity, and the blue line would cover everything from 4.99 to the right and keep on going to infinity. But together, those two lines cover the entire number line, from positive infinity to negative infinity. And so our solution is all real numbers. That no matter what number we choose, it will work for one or the other. It doesn't have to work for both. It just has to work for one or the other in a disjunction. All right, that was a really quick lesson today. So today we defined disjunctions. Disjunctions look at inequalities and tell us which solutions work for one or the other. Remember, our keywords there are either or. It has to work for either one or the other. We solved and graphed disjunctions. That helped us visually see which solutions worked for either one or the other. So the keywords for conjunction, both and. The keyword for disjunction, either or. If you guys have any questions, be sure to write those down and ask me next class.